Okay, so we got a head start on this set of notes, and by we, I mean you guys and Kim. Uh, by sort of having done this section already, um, you know, simply finding the greatest common factor between a set of terms. So if you don't remember exactly, the greatest common factor between two or more numbers is going to be the largest number that evenly divides each number. It's called the greatest common factor because it is the greatest factor. It's the greatest number that is a factor of all the things you're looking at. If it's a factor of all the things, it's common to the things you're looking at. It's shared. Not common like numerous, but common as in that they're shared between them. And for any variable terms, how can you tell what the greatest common factor between any number of variable terms is? Right, it's the lowest power that appears. If there's any terms with no variable, then a variable is not going to be in your greatest common factor, because then the lowest number of times that it appears is none. So an example of that would be example 9. There are all these variables here, but they never, but no term has all of them, this one has XY, but it doesn't have the others. This one has AB, but it doesn't have the others. And this one has CD, but it doesn't have the others. So the lowest number of times that X, Y, A, B, C, or D appear is none. So the greatest common factor is not going to include any of them. And actually, the coefficients too. There's no number other than 1 that is shared as a factor between 12, 13, and 17. And so the greatest common factor, if you could even call it that, is 1. And what can you say about that set of terms if that's the case? If there's no greatest common factor. Yeah, that's it's called prime. So that's sort of what you talked about yesterday. Is everyone sort of okay with that so far? It's okay if you aren't. Okay. Now we're actually going to talk about, not just finding a GCF. We will find GCFs, but not just finding a GCF. We're going to talk about factoring them out of a binomial or a trinomial, or probably not much more than a trinomial. But you might notice that for these, instead of being a sort of comma-separated list of terms, that they are actual expressions, with minus signs and plus signs and everything, separating the terms. Still going to start off the same way. You are still going to think about finding the GCF the same way. Did you guys do example 1? Or okay. So don't mind the pluses and minuses for now. Just think of the individual terms that are being separated. So between the numbers 24 and 18, what is the greatest common factor? What is the biggest number you can think of that goes into 24 and 18? 6. Okay. So the greatest common factor is going to have 6. Now for the variables, there is a variable on this first term. Is there a variable on the second term? No. So what's the lowest number of times that variable appears? 0. It appears 0 times on the second term, you can say. Or you can just say, hey, it doesn't appear in both terms, it can't be part of the greatest common factor, whichever way you want to say it. So the greatest common factor is just 6. Now that that is sort of established, we're going to factor out 6. And what I mean by that is, factoring out is a process where whereby you sort of take a greatest common factor, like 6, sort of out of each term. It's the reverse, in a way, of distributing. So when you distribute, you have something in the front of like a set of parentheses. Okay, yeah, I don't know why I'm describing this with words. So like when you distribute, let's say you got, I don't know, something like that. When you distribute, you take the 4, right, and you multiply it onto every separate term, like within the parentheses, right? Okay, so that you end up with, 4x squared minus 24. Okay. Factoring out the greatest common factor is the opposite of that, where, you take, where you might recognize that, hey, this has a, this is distributing, okay. Factoring is the reverse of that, where you're recognizing like, hey, 4x squared and 24 have the factor 4 in common. I'm going to take that out of both of them. And if I do that, if I take a 4 out of 4x squared, I'm going to end up with x squared. If I take a 4 out of minus 24, I'm going to end up with a 6. And that 4 that I took out, I'm going to write it in front of a set of parentheses enclosing, what I decided that I had left. And so I end up with, this expression 4 in front of this set of parentheses. Sort of, what I have up there. It's in that way, it's factoring out is the reverse of distributing. I'll erase that later. So the greatest common factor for number 1 is 6. We're just going to do this intuitively at first, but I will show you a sort of more rigorous. I mean, it's like that much more rigorous. But just sort of intuitively at first, if you have 24x and you sort of take out or draw out 6 from that, what are you going to have? 4x. Okay. What about minus 18? What if you draw 6 out of that? What are you going to have left? 3. Okay, so a minus 3. Make sure to keep the sign whatever it was before. And that 6 that I took out, I'm going to write it in the front. And you'll notice that if you were to distribute that 6 back into, onto the 4x and the minus 3, you'd end up with what you started with, 24x minus 18, if you distributed that 6 back. So you can tell that these are the same thing, just written different ways. Okay, so when I asked what happens if you take 6 out of 24x, when I asked that, almost everyone said, I'm pretty sure everyone said that you have 4x left. What did you actually do with the 6 and the 24x to get 4x? Divide, yeah. So that's actually all you're doing. In the same way that when you distribute, you multiply onto, and when you're factoring, you divide out of. Okay, so that is fully factored. And just to check that it's fully factored, is there anything you can take out of both 4x and 3? No. So that is fully factored. What's the... Okay. And we'll still go slow with the GCS for now. greatest common factor for this one. Yeah, right. Between 8 and 12, that greatest common factor is 4. What about in between? What about between w squared? You know, the variable term w squared, and the variable term w to the 6th. What's going to be the greatest common factor between those? Yeah, it's always going to be the lowest number of times that a term that a variable appears. So it's 4w squared. And it's got to be the lowest times that it appears, because I mean you can't say that w cubed is the greatest common factor, for example, because like there's only 2 of them here, even though there's 6 of them here. You can't take away more than 2, because this one just wouldn't have enough. So it's got to be the lowest exponent for each variable. Okay, so it's 4w squared. And this would probably, when you're involving exponents like this in your GCF, that's probably when it's good to actually like express what you're doing as a division. So I'm just going to take each of these terms here, each individual term, and divide it by my greatest common factor of 4w squared. That way I'll know what I'm going to have in my parentheses. So I'm going to set up my parentheses. If you want, at this point, you can write down the greatest common factor that you're going to factor out. You know that it's going to be in the front of this set of parentheses that has the remaining stuff in it. If you take 8w squared and you divide it by 4w squared, well, actually, what's 8 divided by 4? Right, that's 2. What's w squared divided by w squared? Yeah, it cancels out, and it's like 1, or you can just not write that it is anything at all. It's not 0, but like you don't have to like write that it's 1. It's just all I'm saying. Right. So 12 divided by 4 is 3. What about w to the 6th divided by w squared? Yeah, because you're going to take the top exponent of 6, subtract the bottom exponent of 2, and it's going to be an exponent of 4. That's fully factored. And it really is when you start involving variables in your greatest common factor that it becomes a little harder to just sort of do it in your head. So if you like, you can express it as a division, as long as don't forget to write the greatest common factor on the outside. So that was this sort of thing is what the previous section was sort of the previous set of notes was preparing you for. Dividing polynomials by monomials, that's part of what you're doing here. Okay, why don't I just use those? All right, so I'm going to find our greatest common factor. Numbers first. The greatest common factor between the numbers 60, 12, and 18. What do you guys think that is? 6, right? Yes. Yeah. So your greatest common factor is going to have 6. And does a variable appear in every term? No, so your greatest common factor is not going to have a variable in it. So your greatest common factor is just 6. Okay, so this should be one that's easy enough to do, like sort of in your head, but like you can also write that you're dividing every term by 6 if you need to. So the greatest common factor is 6, so that's what's going to go on the outside of this sort of set of parentheses that's going to contain everything else that's sort of remaining or left behind. Okay. take 60p squared and take 6 out of that, or divide it by 6, what are you going to have? Okay, 10p squared. Okay. If you have minus 12p and you take 6 out of that, what are you going to be left with? Okay, minus 2p, right? Yeah. And what about minus 18? If you take a 6 out of that, minus 3. Minus 3. So that is fully factored. You can check. There's nothing shared between 10, 2, and 3. There's no variables that all the terms have. That's fully factored. Just looking ahead here. Wait, what? Right. Okay, that's gonna be fun. Okay. Okay, I'm gonna give you all like 3 minutes. 3 minutes is a long time. But I'm gonna give you all 3 minutes to sort of just try this one on your own, and then we'll sort of brush through the last one so we can move on to the next section.
I have a question.
Yeah.
I'm skipping ahead, but for number 5, would the greatest common factor be x squared?
Yes. Okay. Yeah, because coefficients are 3, 1, and 9, there's nothing that's shared. But x does appear in all the terms, and the lowest exponent that appears is x squared, so that's going to be the greatest common factor.
Is 1 right?
Oh,
On 5?
on 5? Oh, you mean the greatest common factor between the numbers 3, 1, and 9?
Yeah.
Yes, yes. So you don't have to include it as part of your greatest common factor. Because 1 is going to divide everything, right? So it's not really meaningful. Like, it technically is, like you can say that it's part of your greatest common factor, but it's not necessary when it's 1 like that. How's everyone doing? Okay. So hopefully, everyone was able to get that the greatest common factor was 4C. Yeah. Right, 4 from 8, 12, and 44, and C because it's the lowest power of C that appears in all of the terms. So in that case, if you take a 4C out of every one of these, you can, of course, write it as a division. So long as you remember to write that greatest common factor in the front of a set of parentheses. And on the inside of that parentheses, you're going to have 2C to the 4th plus 3C minus 11. Now for this one, talked about it a bit already. The greatest common factor is just going to be x squared. Because between the numbers, there's... Let me just write in a little 1 right there. You don't actually have to write it in, but like that's what the coefficient is implied to be if there is none. It's a 1. So between 3, 1, and 9, there's no real... I mean, I guess there's 1, but that doesn't really count. 1's a factor of everything, so...
The 3C, would that be a negative? Oh, no.
And I'm just going to use a third color because there is a second kind of variable here. There's a y on this last one. But there's not a y on the other one, so it's not going to be part of our greatest common factor. There is a variable that is shared between all three terms, and that is x, the lowest power of which is x squared. So x squared is the greatest common factor that gets written on the outside, and I'm just going to divide every term by x squared. And so 3x cubed over x squared is 3x. X squared over x squared is 1, so plus 1. And 9x squared y divided by x squared, the x squareds are going to cancel out, and you're going to be left with 9y. So these are in their fully factored forms. Now the last three of these look a little weirder, but that's for a good reason. It's about, it's for what's coming up. But it's fine. They work the same way. Okay. So this one is still like the others. What's the greatest common factor here, just between these terms? 4x. Yeah, but the greatest common factor between all the numbers is 4, but the greatest common factor between all of these terms here as they're written is 4x. So 4x gets written on the outside, and you can, of course, divide each of these by 4x to know what is going to be in this set of parentheses. What are you going to get if you take negative 4x? Yeah, you're going to have negative, the 4's are going to cancel out, but the negative's still there, and x cubed over x, that's x squared, so negative x squared. What about 32x squared divided by 4x? 8x. Yeah, you're going to have an 8 from the 32 and 4, and x squared over x is going to be x. Okay. And what about this last one? Negative 20x, or I'm just going to write the minus there. Right, it's going to be a minus 5, because the x's are going to cancel out. 20 over 4 is 5. So that is fully factored. Let's come up anywhere else. Yeah, I don't think so. Okay. So that's good for now. This is going to be a bit of a weird question, but how many terms are there in example 7? Like ultimately, how many terms are there? I know it looks like there are several. There are two. There's this big plus sign in the middle. There's one term here and one term here. So a factor of a term is anything that is in the term that's being multiplied by something else, or that, you know, that's being multiplied by something else. So you got to think of these as being, you know, two factors right here. One of the factors is x, and the other factor is 6x plus 5. Like that is one factor. 6x plus 5, because it is in its own set of parentheses. It collectively, or as a whole, is being multiplied by the x. So it is one factor. Same with this 9 that's on this term. It is its own factor. But so is this 6x plus 5. That's also its own factor. And so there are these two terms made up of two factors each. Is there a factor that is shared between these two terms? Right. The parenthetical expression 6x plus 5 is on each of these two terms. So I'm just going to highlight that that's in each term. Okay. So that is the greatest common factor. The entire factor, 6x plus 5. And just to be safe, I'm going to write that, that factor, because things can get messy if I don't write it in parentheses. I'm going to write that in its own set of parentheses. It's surrounded by parentheses is a factor, and it's a factor on each of those two terms. Okay. So I'm going to write my greatest common factor out in front of a set of parentheses, my greatest common factor being the 6x minus 5. I'm going to write that in front of a set of parentheses, and the set of parentheses is, the set of parentheses that's open right now is going to have all the stuff that's left over. So that first term, if I take out my greatest common factor of 6x plus 5, what do I have left? Yeah, so the x, and right, and for the second term, the 9, right? Yes. It only took me 43 minutes to make my first mistake. But yeah, that's fully factored. Sometimes factors can be these expressions that are wrapped up in parentheses. Factors don't just have to be monomials all the time. Sometimes factors can be binomials. As long as they're being multiplied and they're shared between the terms, they can be part of your greatest common factor.
So that's the answer?
Yes, this is the fully factored form of what you have here. And just like with all the problems before, if you can sort of imagine taking this and distributing it onto the x and onto the 9, you would end up back with what you started with, right? if you took that 6x plus 5, multiplied it onto the 9, and then took that 6x plus 5 and also multiplied it onto the, I should have said x first and then 9, but, you know, then you would have, like, the expression that you started with. Here. Okay. And, you know, we're going to do 2 more of these ones where the factors are, you know, these weird little parenthetical expressions before moving on to the next one. Before moving on to the next sort of concept, factoring by grouping, which very conveniently uses this as, you know, part of the basis for it. How many terms do you see on example 8? 2, right? There's 1 here, there's a minus sign, and then there's another term. What factor do you see that is on each of the 2 terms?
5y minus 2.
Yeah, this sort of parenthetical expression 5y minus 2 is on both of them. Is there anything else that the 2 terms share? No, right? I mean, 6 and 5 don't really have much. There's a y on the first term, but not on, you know, there's a lone factor of just a y on the first term, but not for the second. So this is your greatest common factor. Five y minus 2. Okay, so 5y minus 2 is what you're going to write in front of, you know, your set of parentheses that's going to contain all the stuff that's left over. What is left over after you take out the 5y minus 2 from every term?
6y minus 5.
Yeah, that's it. Just the stuff that's in front. 6y minus 5. Is this extension of factoring stuff out still seeming weird? Or is it like fine? Okay. That's good because I don't know what I would have done if somebody said yes. I don't have anything else. Okay, so again, 2 terms here. There's a term here, a minus sign, and then a second term here. What factor is on each of those terms? Okay. Is there anything else? No. So x minus 3 is the greatest common factor. I should probably write that. In parentheses, right? And in parentheses in front of this set of parentheses as well. What's left? Okay, 3x minus 2. That is, you know, that along with the greatest common factor of x minus 3 and in front is fully factored. Okay. So the next thing we're going to talk about is factoring by grouping, and it's something that's only, well, I wouldn't say it's only possible when you have 4 terms, but I mean, it's not like you're going to see it with 6 terms or 8 terms or anything like that. So if you see 4 terms, this is going to be a technique that your mind should sort of immediately snap to for now. So you'll notice that, well, I mean, if you noticed, how many terms are in every one of these? 4, right? So what you're going to do is you're going to break up each of these quadrinomials, tetranomials, these four nomials into 2 pairs, a sort of front pair and a back pair. And you know, a way to help with that is to take a pen or pencil, like the thing that you're doing this with in the first place, and just put a little, just do that. And an important thing is going to be, make sure that the sign in the middle is with the third term, the term that it's in front of. Please do not, don't do like this, don't go right through the middle sign, and don't leave the middle sign, behind. Make sure it is on that third term. Okay, so that sort of splits up these four terms into two pairs of terms. And what you're going to do is you're going to factor each of these terms individually. Right, and it's just a pair of terms, so that's fine. Yeah, so that is correct. That is correct. The greatest common factor for the first pair is x. Okay. So you don't have to, if you're not told to do so, you don't have to write the greatest common factor each time. But I'm just going to try to fit it in while I still can. So the greatest common factor here is x, right? Because coefficients are 1 and 2. There's nothing there. The exponent, or like the variables, they both have an x. Lowest power that appears is just a regular x, so that should be in my greatest common factor. If I do factor that out, what is left after I take that x out of each of those, just those two terms in the beginning? Okay, yeah. The x squared is gonna, once an x is taken out, it's gonna become an x. And the 2x, after you take an x out, is gonna become a plus 2. And then you just sort of close off that parentheses for now. Now we're going to repeat the process with the second, the back pair of terms. That is right. Greatest common factor is 6, between 6 and 12. This term here doesn't have an x, so x can't be part of the greatest common factor. The greatest common factor is just 6. So now when we write this, I'm going to make sure to convey that there was this plus sign here. So I'm going to write plus 6. And then I'm going to open up my parentheses like usual. And if I take a 6 out of each of these two terms in the back half, what am I going to have left over on the inside? X plus. Yeah, 6x, take a 6 out, that's x. 12, take a 6 out, what's that going to have? What's that going to leave? 2. So plus 2. Does what you have here at this stage maybe look a little familiar? Yeah, it's sort of the thing that you had immediately prior to this, yeah. Where there's this sort of a factor that's on, each of two terms. So we're going to end this by factoring out that x plus 2. That x plus 2 is on each of the factors there. Got to make sure it's in parentheses. And if I take that x plus 2 out, what's going to be left over? X plus 6. That is this 4-term polynomial fully factored. So you don't always have to think of it, in this sort of way that we've been thinking about. A way that you can think of it is, so it's perfectly fine to do what I just did. But if you're still finding that a bit weird, one thing that you can just sort of do is there's this repeated factor on each term, right? That should be one of the factors that you end up with. Then there's the stuff in front. You collect the stuff in front together, and that's going to be your other factor. Right? So one factor will be the repeated factor of x plus 2. The other factor is going to be the stuff in front collected together, that's x plus 6. Whichever, like they're the same thing, It's just not as explicitly described as, like a factoring out of that x plus 2. So I'm going to try to factor this by grouping. Where should I put the line that sort of separates the front half and the back half? Yeah, right before this middle plus right here. Okay. What's the greatest common factor? So I'm just gonna sort of like put little parentheses here. But what's the greatest common factor for this first pair? Okay. Between 9 and 6, it is 3. And between x squared and x, the lowest power is going to be x. So 3x is going to be the greatest common factor here. If I do take out a 3x from each of these two terms here, and again, there's no problem with describing it as a division. Right, greatest common factor is 3x. You can divide each of these terms by 3x, no problem. But that 3x is going to be in the front. And what are you going to have left inside? 9 divided by 3 is 3, and x squared divided by x is x. Yeah, so that first term is going to sort of reduce to 3x, or like, it's going to become 3x once you take 3x out. What about 6x divided by 3x? Just a plain 2. The x's are going to cancel out. Now, before we even start on the back half, there's going to be some sort of greatest common factor here. What do you think is going to be left over here when we were done with this? Don't actually like try to do it or anything, but like, what can you probably expect is going to be left in this second set of parentheses? Yeah, there's probably going to be a 3x plus 2. Like, I don't even know that for certain because I haven't looked at the back numbers, but like knowing that this is factoring by grouping and that this is like what happens when you try to factor by grouping, or like what is supposed to happen when you factor by grouping, I can fully expect that second set of parentheses, once I factored something out, to contain a 3x plus 2. Yeah, a 5 would be like in front.
No. For the greatest common factor.
The second part is 5.
Yeah.
No, but like.
Yeah.
No, but instead of it being 3x plus 2, it's x plus 3. Does that make sense? Am I coming off right? Because if you take 5 out of both of it, you get the x, and then you get the 3.
Right, you get 3x, and if you take a 5 out of 10, you get 2. So 3x plus 2?
Well, I don't, wait, which one are we on again?
Example 2?
Oh, sorry, I wrote down, I'm sorry. I went down. No,
Okay.
please. I'm looking at the wrong answer.
Okay, so the greatest common factor for the second pair is 5, between 15 and 10. There's no x on the last term, so but yeah, make sure to write a plus 5. You don't want you don't want to make like you don't want to just do that, because then it looks like you're just multiplying 4 things together, which you're not. Make sure to write that plus. And this should be easy enough to do without having to write it down as a division. 15x with the 5 taken out is 3x, and 10 with, you take out a 5, you're left with a plus 2. Okay. Now, you could, of course, go through the whole trouble of, saying you're factoring this out and, that there's going to be the 3x and the 5 left. But if you didn't want to, what's the repeated factor here? Three x plus 2. So that's going to be one of your factors. A mistake that people make sometimes is they think that because it's repeated, that it should appear there twice. That's not the case. The repeating is like just what tells you that you're doing this correctly. And what's the stuff in front? If you sort of, 3x plus 5. Just collect that into one factor, 3x plus 5. And that is your fully factored, expression. If you did go through the trouble of foiling this, take the 3x plus 2 as one binomial and 3x plus 5 as the other binomial. If you did foil this, you would find that you would end up back with the original expression 9x squared plus 6x plus 15x plus 10. Man, there's a lot of factoring by grouping. Okay. Okay. Draw a line. Make sure to leave the middle operation symbol with the second half. What's the greatest common factor for the first pair of terms? 6. Yeah, that's right. Yeah. Can't go. That's right. 6 and 6 for the numbers and x for the variables. While we're up here, what's the greatest common factor for the second pair of terms? Just a plain 7. That comes from 35 and 21. Yeah. Okay, so we'll factor out a 6x from this first pair. And what's that going to leave us with inside the parentheses? Okay. Yeah. It is going to be 5x plus 3. And as always, you are entirely free to express the division that you're mentally doing here. 30 divided by 6 is 5. X squared divided by x is x. And 18x divided by 6x, that is a plus 3, because the x's are going to cancel out. Okay, if you factor out, for the second half, the greatest common factor is 7, a positive 7, so we'll write a plus 7. If you factor that out, what are you going to be left with from the back pair? Okay, right, 5x. And what if you have 21 and you take out a 7? 3, right? If you sort of divide the 7 out, you're going to have 5x plus 3, which, very coincidentally, big surprise, is the same as the 5x plus 3 from the first pair of terms. So we'll just, make a note that that is a repeated factor. You can either say, the repeated factor or the factor that comes from the stuff in front, but what is one of the factors going to be? Okay, 6x plus 7 will be one of your factors. What's your other factor? That repeated 5x plus 3. because definitely the most exciting part of this is going to be this back page here. And I want to make sure that I dedicate enough time to it. Okay, so split up these terms. Yeah, let's split up these terms. This is going to be important. Make sure that minus sign is on the back half of, the back pair of terms. So I'm not going to be writing down greatest common factors anymore. What's the greatest common factor of between p squared and 8p? P. Okay, if you take a p out of each of these two terms, what are you going to be left with? Okay, p plus 8. Great. Now, there is something different about this one. That's a negative p minus 8. Generally speaking, if you want to make sure that your leading term, whatever term comes first, is positive. What that means is that if you have your leading term, and right now I'm talking about this minus p, if you have that being negative like it is here, you want to factor out a negative sign, at least. So if you factor out a negative sign, if you just sort of say, I'm going to take a negative sign out of both of these terms, that's going to flip the sign of each of those two terms that's right there. You're sort of sucking the negative sign, right, from those two terms. So if you take a negative sign out of each of those two terms, what are you going to have left? P plus 8. The negative p becomes a p once you take the negative out, and negative 8 becomes a positive 8 once you take the negative out. Okay, so certainly this factor is repeated. That should be one of the factors. And this looks a little bit weird because there's nothing in front except a minus sign, but a minus sign with nothing else actually represents a negative 1. So you can write that 1 in there if you'd like. And so the factor made up of the stuff in front is going to be, what is that going to be? Yeah, p minus 1. Yeah, don't forget that the 1 is there and then just write like that. That's not anything. Okay. Okay, we'll get through the rest of these pretty quickly. We'll skip example 7. It's just another very regular one where there's the minus sign in the middle, so you have to remember to factor out a... No, it's... we'll just try to do it quickly. Greatest common factor of this first pair, 5x. If you take a 5x out of each term, what are you going to have? Okay, x from the first and minus 3 from the second. Now you have a negative 2x plus 6 as your second as your second pair. So, of course, like number-wise, you're going to want to take out a 2 as your greatest common factor. But because of that leading term being negative, what are you also going to want to take out? Yeah, you want to take out a negative 2 specifically. And if you take a negative 2 out of each term, the negative 2x is going to become what? Just x. And what will this positive 6 become if you try to take a negative 2 out of it? Negative 3, or minus 3, yeah. Okay, so one factor is x minus 3. That's there each time. And the other factor is 5x minus 2. What's the greatest common factor for this pair of terms? T. That's the only thing that's in both of these. And if you take a t out of each term, you're going to be left with r plus 3. And what about the second pair of terms? What are you going to want to factor out? Negative 5. and you're going to be left with r plus 3, right? That's a minus 15, but if you take a negative 5 out, it will be a plus 3 left over. So one of the factors is r plus 3, the other factor is t minus 5. Okay. And I think it'll be fine to just do one of the remaining ones. Okay. And I'll you guys seem to have the sort of factoring out a negative thing down, so we'll just do example 9 and skip example 10. Okay. Between this first pair, what is the greatest common factor between 6x squared and 3xy? Okay, yeah, 3 from the numbers and x from the variables. Take a 3x out of each of these two terms, and what are you going to be left with? 2x, right, from the first term, and take a 3x out of 3xy, you're going to be left with a plus y. Yeah. Okay. From the second pair of terms, what's your greatest common factor? Yeah, plus 2y. Yeah. And if you take a 2y out of each of these terms, what are you going to be left with? Mm-hmm, 2x from the first term. And what happens if you take 2y squared and you divide it by 2y? Sorry, what's that? Yeah, plus y. Alright, we'll skip this one, but you can do it if you want to. I don't know why you would. You're going to have enough of this stuff on the actual assignment. Okay, so the last thing is going to be a process for which there are many methods. And I'm sure, like, between all of you, you have learned probably every conceivable different way to factor a trinomial like this. We could probably spend a week on all the different ways. What's referred to as a split B method here, the way that works is, and we're not actually going to learn, what is referred to as a split B method. We're going to learn something else. That's the method where you take whatever the middle term is, first you find two. The method that we're not going to learn is one where you multiply the first coefficient and the constant. So, like, for example, we would say 1 times 20 is 20, and we try to find factors of 20 that add up to 12, right? That part's pretty common to all the methods. But then, once we found that pair of numbers, it's 10 and 2, by the way. 10 and 2 are the numbers that multiply to 20 but add up to 12. Once you find those numbers, you split it up. You split up the 12x into, say, 10x and 2x. Like, you use those two numbers that you found to sort of split the b term. That's why it's called the split b method. And then you just factor by grouping, as we always have done. So that is an option that is available to you. It's just like one sort of extra step removed from what you guys just learned, if you want to do it that way. Did anyone here happen to learn it that way in school? Okay. Yeah, it's fine. It's fine. I like to I like to do that way sometimes. But there are definitely more sort of intuitive ways out there. Okay. And once you sort of get the method down, these are going to go quick. These ones where there's a number in front of the x squared, maybe a little less quick, but now what you're going to see Kim write a lot is this sort of cross. And she's going to call it a diamond, and you need to not say anything. Like, I guess it could be a diamond if you enclosed it with a thing, but like it's clearly a cross. So for these sort of simple ones, sort of notice how example 1, 2, and 3 are different from the following, well, from a lot of the following examples. They don't have anything in front of the x squared, right? They just start off with a regular x squared, right? These are going to be the easy ones. I mean, not that the other ones are like hard, but like these are going to be the very quick ones. Okay, so in this little quadrant, I like to put a little multiplication symbol, and the number that I want to multiply them to is going to be the constant. And down here, directly opposite, I'm going to write a little plus sign, and what I'm going to write there is my coefficient for the b term, that 12. That's what I want that's what I want this pair of numbers to add to. So I'm trying to find a pair of numbers that adds up to 12, but multiplies to 20. And depending on how much you manipulate numbers mentally, on your day-to-day, you may be able to come up with this pretty quickly. You may also be able to come up with this pretty quickly because I just said what they were 2 minutes ago. But what are these two numbers? Yeah, now specifically positive 10 and positive 2. Yeah. And if you can, make sure to sort of communicate that through the use of a plus sign. Once you have those numbers, one of the factors is going to be x plus 10. The other factor is going to be x plus 2. That's all.
That's your answer?
Yeah. If you FOIL these out, you would get x squared plus 12x plus 20.
So on the that's on both sides of the factors.
Yeah. Okay, so for this trinomial, this trinomial that just starts off with an x squared with no coefficient in front of the x squared at all, what number am I going to want my pair of numbers that I'm trying to think of? What number am I going to want them to multiply to? Yeah, the constant at the end. I want them to multiply to 24. Yeah, and that is a negative 10, so you want to make sure to include that. That is a negative 10. Now, it is, just to see, can anyone think of two numbers that multiply to 24? Right? But if you, yeah, right. If you were to add 6 and 4, you would end up with positive 10. However, if you did negative 6 and negative 4, that would still multiply to positive 24. But this time they would add up to negative 10. So those must be your two numbers, negative 6 and negative 4. What's up? I'm going to show you a way to sort of help you come up with factors on the calculator. Although you will still have to check that they add up to the correct thing, sort of yourself. So if you go ahead and grab your calculator, take the number that you want your pair of numbers to multiply to. What number was that?
How do we get to that?
Oh, just press this, y equals. What number did we want our pair of numbers to multiply to? Okay, this time it was 24. Now take 24, put 24 there, place a division symbol, and press this button, this one that says x, t, theta, n, to place an x. Okay. That's just gonna go ahead and divide 24 by a bunch of numbers, and it's gonna form these sort of pairs of factors of 24. Now don't press graph, press second first, and then you'll notice above it in blue it says table. That's what we're trying to get to. So press second first and then the button that says graph on it. And each row is a pair of factors, right? 1 and 24, 2 and 12, 3 and 8, 4 and 6. If any of the rows have non-whole numbers in them, you can ignore them. You're looking for pairs of whole numbers. So you know for a fact that these multiply to 24 because that's literally how you sort of designed this. So you already know that all of these pairs multiply to 24. So what you want to check is there a pair that adds up to -10? So obviously none of these are going to add up to a negative number. These are pairs of positive numbers. So if you sort of go up here, you might check, okay, well this row adds up to, if I added these two numbers together, I'd get -25. If I added these two numbers together, I'd get -14. If I added these two numbers together, I would get -11. That's really close, but not exactly. And if I added these two numbers together, I would get -10. So these must be your two numbers. -4 and -6. Is this knowledge helpful? Okay. So yeah, just remember that you do that by pressing y equals, putting the number that you want them to multiply to, so the number at the back, the constant, and a division symbol and an x. Not 244, but 24. Okay. And then you can view the table by pressing second and then the button that says graph. And you can scroll up and down as you need to. Just keep in mind, obviously, positive numbers, pairs of positive numbers are not going to add up to negative numbers. So, you can sort of use that to sort of narrow down your search. And vice versa. Pairs of negative numbers, if you were looking for a positive number, negative numbers will not add up to a positive number. Okay. So anyways, these are our two numbers. Meaning that our factors are going to be x minus 6 and x minus 4. Okay, so what do we want? We want a pair of factors, but what do we want them to multiply to in example 3? Okay, we want them to multiply to -6. And what do we want them to add up to? Okay. Now, this -6 stuff trips a lot of people up because it changes depending on what the sign is. Sometimes it's the pair 6 and 1, sometimes it's the pair 2 and 3, all depending on what the signs of each of these are. But you can, of course, say, I want to form -6 divided that by x on your y equals page here, and try to find a pair of numbers that adds up to -5. Do you guys see a pair of numbers that adds up to -5? That's not a pair though. We have a -3 and +2, and we also have -2 and +3, but we don't have them both being negative. Yeah. In fact, the only pair that adds up to -5 is going to be this -6 with this +1. -6 plus 1. So there's going to be two factors. One is going to have a -6. The other one's going to have a +1. Okay. Okay, so now the reason that these have started, each factor has started with an x so far is because each of these trinomials have started off with an x squared, right? So that's got to come from an x times an x. So that's why there are two factors each starting with an x. So that when these two factors get multiplied together, not that you're actually going to do that, because that would just undo the work you did, but if you were to multiply them together, that x would get to multiply by that x and form this x squared. And sort of the same thing here. This constant would get to multiply this constant, and it would form the number in the back here. This trinomial starts off with an x squared, so its factors are also probably going to start off with an x, and you can write that in right away. That last term has a y squared on it. So what are our factors probably going to end with? Each of them, yeah. Some amount of y's. There's still going to be numbers involved, but that's just what's going to be on them. This one you're going to be able to do in your heads. We want them to multiply to +4. But we want them to add up to +4. Yeah, +2 and +2. So, x plus 2y, x plus 2y. Okay. Starting at this point, what's different about these? Yeah, they're no longer plain x squared. They're like 2x squared, 3x squared, 2n squared, 2x squared, 8x squared. So the method that we're going to learn for dealing with these, you can do whatever you want, but the method that we're going to learn is referred to as slide and divide. Did anybody learn anything by that name in their time in class or at school? Okay. How did you guys learn to deal with this stuff?
I don't remember long.
Okay. Right, and it's called slide and divide, first of all, because that rhymes, and that makes it easier to remember, I guess. But because that is also a description of what you do. So when you slide and divide, and you only have to do this if the trinomial starts off with a coefficient, other than 1. So a 2 or a 3 or an 8 or a 4. What you do is you take the coefficient in front, and you slide it to the back. And you multiply it by that constant on the end there. This reduces the trinomial to something simpler. Right? You're just going to have a plain x squared now, plus 11x, plus, what's 12 times 2? 24. So this temporarily reduces this thing to a simpler polynomial or a simpler trinomial. And on this, you're going to do the exact same thing as you've been doing. What are, you're probably able to do this without the calculator maybe. Not that, there's no shame in using the calculator though. What are two numbers that multiply to 24 but add up to 11? Yeah, positive 8 and positive 3? Yeah. Positive 8 and positive 3. And the way I'm going to write it, I'm going to write them a little higher up. Sort of here. Because there's something I need to put underneath this. Right, so this is called slide and divide. We already slid, but now we must divide. And this is when we're going to do it. What number did I slide? I'm going to now divide by that same number. Does 3 over 2 reduce at all? No. Okay, yeah, well, it's fine. I'll circle it now. Does 8 over 2 reduce? Yes. Just to a plain 4. Okay. So one of my factors is, of course, going to be x plus 4. The other factor, well, you might think that it's going to be like x plus 3 over 2. That's not really how it works. If something doesn't reduce like that, if something is a fraction still, what you got to do is you got to take the bottom number, so that 2, put that next to the x. So it's going to be that 2 times x, and then whatever number you have on top, so plus 3. Right, only if one of the terms starts with an x and the other term starts with a 2x will your result be able to start with a 2x squared. Are you mad?
No, I'm getting the eraser.
Oh, okay.
I didn't realize that. Good. Okay.
Okay. So we're gonna do. We're gonna try to squeeze out 2 more of these. Okay. And when you guys go home, I'll have this uploaded so you guys can just watch it again if you. Yeah. All right. So we're gonna take this 3 and we're gonna slide it to the back. And what new trinomial is that gonna form? Right, just plain x squared now, minus 16x. Then what number is at the back here? Yeah, it's a plus 15. Okay. Actually, I should probably do that down here. So I want 2 numbers that multiply to what? 15, okay, and add up to this negative 16 that's in the middle. And the 2 numbers that do that are that add up to negative 16, yet multiply to positive 15. Negative 15 and negative 1? Yeah. And because we're going to slide and divide, I'm going to write them a little bit higher. Negative 15 and negative 1. Okay, and I'm going to slide by this, I'm going to divide by the same number I slided by, yeah. Okay. Does negative 1 over 3 reduce? No. So that's just going to be used as it is. It's going to get flipped up all around and stuff. Yeah, negative 15 divided by 3, what's that going to be? Okay, negative 5. So that is going to reduce, and that just gets to be a plain negative 5. So I know that one of my factors is going to be x minus 5. The other factor, that is one that did not fully reduce to a whole number. So I'm not going to be able to just use it. Like, please don't just go like this. That's not going to, if you try multiplying that back, that's not going to end up with 3x squared minus, all this other stuff. That's not going to work that way. Okay. Yeah, it is. Whatever number is on the bottom, that's the coefficient for the x. Whatever number is on top, that's the constant that goes next to it. So it's that 3 that's next to the x, and just the number that's on top, including whatever sign it is, right next to it. And that's fully factored. Negative 24, that up to negative 5. And negative 3. Negative 8 and 3, okay. 6 up to 5, right? 8 add up to positive 8 that add up to negative 3. I think this one's possible. I think this one's prime. I can't think of two numbers that multiply to 8 but add up to negative 3. So that one would be one that is unfactorable or prime. Just because I can't imagine, sliding that 2 to the back, multiplying it by that 4, it would become an 8, and I'd have to try to find two numbers that multiply to 8 but add up to negative 3. There's no pair of numbers that does that. Okay, so we'll skip number 7. Yeah. I'll skip number 7 for now, and if anyone wants to stay after, I don't want to hold you guys after 7:40, which is in less than a minute. But we're going to take this, we're going to slide it to the back, we're going to take that 8 and we're going to slide it to the back. That's going to form x squared minus 5x minus what? Yeah. Okay. And we're just going to try to do, the same deal as we have been. I want them to multiply to negative 24, but add up to negative 5. It even took me a while to think of this. Negative 8 is one of the numbers, and then the other one is positive 3. So minus 8 and plus 3. Now because we started off having to slide, we now have to divide. So if you slide, don't forget that you did it, because otherwise you're just going to write x minus 8, x plus 3, and it's going to be wrong. But we're going to divide by a certain number, the number that we slid, that 8. And we're going to see if any of these reduce. Does 3 over 8 reduce? No. So it's just going to be what it is. But does negative 8 over 8 reduce? Yeah. Into a minus 1. A plain whole minus 1. So what are your two factors? Right. One of them is going to be x minus 1, just from this whole number 1. And what's the other one going to be? Yeah, it's this bottom number first, 8, next to the x, and then whatever number you had on top, so that plus 3. That is fully factored. So there's a number in front of the, it's not an x, it's an n this time, but it's still a squared variable. But there's a number in front of there. There's a coefficient explicitly written there, and it's a 2. So we're going to slide this 2. to the back and multiply it by that c term. Yeah, and it's going to end up being n squared plus 5n minus 6. And we're just going to sort of do the usual process of finding two numbers that multiply to -6, that back term, and that add up to positive 5.
Is it 6 and -1?
Yes. So plus 6. Actually, I'm going to, for space reasons and because I can see the future, I'm going to write the plus 6 right here and the -1 right here. So this was a slide and divide problem, meaning that we're going to have to divide by what? 2. Okay, does -1/2 reduce at all? No. And so it's going to be one of those, like, sort of slightly more fancy factors. But does plus 6/2 reduce? It does to plus 3, and that's just going to be like a regular factor. So one of the factors is going to be x plus 3. And what's the other one going to be? 2x minus 1, that bottom number, then the x, then whatever number and the sign that was on top. So 2x minus 1. Oh, right, yeah, no. These should be n's. Absolutely.
Yes, it is a number.
What's up?
Because technically, if you were using x instead of n, the answer would still be the same, unless you were trying to get back to checking your work. But the variable that's a letter can be interchangeable.
Pretty much, yeah. Like the intention or the meaning is the same.
Right.
Yeah.
So if you were using x instead of n, it wouldn't matter.
Yeah. As long as you're not trying to use both of them like for separate things at the same time, it's okay to mix them up a little bit, I guess. Yeah. I mean, I wouldn't take off points if there was a polynomial in terms of n and someone factored it and wrote x in their factors. Okay. And the reason that this is prime, you can just write prime, but this is why. Try to do the same thing to this. You end up with x squared minus 3x plus 8. Numbers that multiply to positive 8 but add up to -3. There are none. There just aren't. There just aren't. Okay, what other ones do we skip? I think we skipped like 2 here. Yeah. It does. Those are two factors being multiplied, so it doesn't matter any more than like 2 times 3 versus 3 times 2.
Okay, so either way that they're in there, as
Yeah.
long as the what's inside the parentheses.
Right. As long as you don't write like 2n plus 1 by accident or something. Yeah, as long as it's 2n minus 1 in one set of parentheses and n plus 3 in the other set, it doesn't matter. You know. Yeah. I guess we'll just go backwards through whatever else I skipped if you want to stay. The last thing I skipped was a single factoring by grouping problem. And, a reminder, that's where you have 4 terms and you sort of split them into 2 pairs. And you consider one pair at a time. So for this first pair, I could probably stand to zoom in a little bit, probably. Between this first pair, x, y, and 9x, what's going to be the greatest common factor if anyone feels like saying? Yeah, it's going to be x. And if you take out an x out of each of these 2 terms, you're going to be left with y plus 9. Okay. Now, if you do the same with the second pair, you might find that the greatest common factor is 5, except this starts with a negative, so you're going to want to factor out a negative 5. Because only if you do that will you be left with positive y plus 9. Right? You want these to be the same. You want these to be repeated. So here's a repeated y plus 9. That's going to be one of your factors. And your other factor is the stuff in front. This x and this minus 5. That's it. And I'm glad Kim did the first little bit yesterday, because otherwise I would have been much more behind. Okay. And the only other two that is that the only other one I skipped? Yeah, the only other one I skipped was these two like simpler factoring by grouping problems, which I'm still going to do, but I'm just sort of going to do them silently. Because it feels weird to explain them after having explained the more difficult ones. Just if you want your notes to be complete, you know. Why am I doing this in red? Yeah. And so for example 4, if you can't find anything to factor out, you can always factor out a 1. And this other one, greatest common factor is x squared, x minus 4, okay, and then it's 5, leaving you with also x minus 4. Okay, well, that means that that's one of the factors. And your other factor is going to be this stuff in front. X squared plus 5. Okay. So those were the ones I had skipped earlier. Example 4, should probably use a color I haven't overused already. Okay. Example 4, example 5, and example 10.